Hello listeners and viewers. Welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration, under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned as always to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Good day, learners at home. You are welcome to yet another physics lesson on radio, television, e-learning program of Ministry of Education, Kaduna State. Today, we are still continuing with the topic gravitational field, and we will look at part 3 of gravitational field. My name remains Hassan Buki. In our outline, we have escape velocity, weight of an object in space, then assignment. Escape velocity, V subscript capital E. Objects like artificial satellites move around the Earth in an orbit. They are held, or we can say they are kept, in their circular path by the Earth's gravitational pull. And this is the force that provides the needed centripetal force required to keep the satellites in their orbits. Now, in circular motion, we saw earlier before now in SS1 that all objects that move in a circular path have acceleration directed towards the center of the Earth. And so therefore, all these artificial satellites that move around the Earth are pulled towards the center of the Earth by the Earth gravitational pull. Now, this Earth gravitational pull provides the centripetal force that is required to keep them in their orbits. That means to continue moving in a circular path, because we said the force that is required for any object to remain in its circular motion is known as centripetal force. Here we have our diagram. We have the Earth, then we have the Moon, okay, which is a natural satellite revolving or moving around the Earth. And what keeps this Moon in its orbit is the Earth's gravitational pull. So centripetal force is given by the equation F is equals to mass of satellite times square of the velocity of satellite over radius of the Earth, and we call it equation 1. Now this equation also, if you remember back to circular motion in SS1, already we saw that centripetal force, one of the equations to determine centripetal force is mass of the object times square of its velocity divided by the radius of the cycle in which the object is moving. Now we have where capital F is our centripetal force, m subscript s is our mass of satellite, vs is our velocity of satellite, and re is the radius of the Earth. So Earth gravitational force is given by, just like we saw in our gravitational field part 1, that the Earth's gravitational force is given by F is equals to the universal constant g multiplied by the mass of the Earth times the mass of the object. And here our object is satellite, all divided by the radius, the square of the radius of the Earth. Therefore, we have capital F is equals to capital G, small m subscript e, small m subscript s, all over or divided by r subscript e squared. And that gives us equation 2, where our m subscript e is the mass of the Earth. Now, if you look at the first equation and the second equation, they are all forces, which means we can therefore equate equation 1 and equation 2. Now, equating equation 1 and equation 2, we will now have ms vs squared over re is equals to g me, that's capital G, me ms over re squared. Now, making vs squared the subject of the formula, we will now have vs squared to be equals to gme over re. Why? Because ms is appearing in both sides. So ms will cancel on the left hand side, will cancel ms on the right hand side. And therefore, we have vs squared to be equals to gme all over re. Now, taking square root on both sides so as to get vs, we will now have vs is equals to square root of capital G me over re. And we say this is our equation 3. Now, if you look at in equation 3, the mass of satellite ms does not appear in the equation. This means therefore that all satellites moving around the Earth with radius re, that is radius of the Earth, must have the same speed as far as they are moving around the Earth with the radius of the Earth. Then they must have the same speed, no matter the mass of the satellite. The speed with which they will move with will be the same for all of them. Now, for a satellite or rocket to escape from the Earth and never return, it must be launched with a velocity greater than that required to keep it moving around the Earth. That means to project or to launch any object, to never to return back to the Earth again, then the velocity that will be required for that object to move and never return back to the Earth again must be greater than that velocity required to keep the object moving around the Earth. Now we look at definition of escape velocity. Escape velocity VE is defined as the minimum velocity required for an object, for example, satellite or rocket, to just escape the gravitational influence of the Earth. That is the definition of escape velocity. I take it again. I said it is defined as the minimum velocity that is required for an object, for example, a satellite or a rocket, to just escape the gravitational influence of the Earth. So here we have the diagram. We have, this is our Earth, and then we have a small mass here which represents our satellite. Now at the center of the Earth, where the mass of the Earth is concentrated, we have ME, which is the mass of the Earth. Then we have capital R, which is the radius of the Earth from the center of the Earth to the circumference of the Earth. And then we have MS here, which is the mass of the satellite. Then our small letter r is the distance of this satellite from the center of the Earth. That means from the center of the Earth to this point. That's the distance of the satellite from the center of the Earth. Now, let ME be equals to mass of the Earth. Our MS is mass of satellite. Capital R is radius of the Earth. Small r is the distance between satellite and center of the Earth. Now, the work done in carrying a mass, ms, from a point at a distance r from the center of the Earth to a distance so great that gravitational field is negligible, is given by work done is equals to force times distance. Mathematically, we have W for work done is equals to capital F, which is our force, then times small r, which is the distance of that mass from the center of the object. But our gravitational force of attraction is given by capital F is equals to capital G ME MS over R squared, and that gives us equation 5. Now, if we substitute equation 5 into equation 4, our equation 4 is W is equals to capital F times small r. So substituting 5 into 4, that means wherever we see F in equation 4, we will represent it with G ME MS over R squared. So therefore, we will now have capital W, which is work done, to be equals to capital G small ME MS over R squared times R, which is the distance of that mass from the center of the Earth. Now, R here, we cancel 1 of the R squared. And then we are left with W is equals to G ME MS all over small r. And we call this equation 6. Now, this work done is equal to the kinetic energy, Ke, of the satellite at this point, having a velocity Ve. That's the velocity of escape. So we know that kinetic energy, Ke, is equals to half mv squared. Therefore, we now have Ke is equals to half, excuse me, ms Ve squared. And that gives us equation 7. Now, if we equate equation 7 and equation 6, since we've already said that this work done is equals to the kinetic energy, so we can equally equate equation 7 to equation 6. Therefore, we will now have half ms Ve squared to be equals to capital G ME MS all over R. Now, if we make VE squared the subject of the formula, we will now arrive at VE squared to be equals to 2gme all over r, because ms on the left hand side will cancel ms on the right hand side. Now, to find VE, we take square root on both sides, and we have V subscript E to be equals to square root of 2 capital G M E over R, and that gives us equation 8. Now, if the satellite is launched from the Earth's surface, then our small r, which is the distance between the satellite, the distance of the satellite from the center of the Earth, will be equal to the radius of the Earth, and therefore small r will be equal to capital R. Therefore, now we will now have V subscript E to be equals to square root of 2 capital G M E all over capital R, and that gives us equation 9. But from our relationship between small g, acceleration due to gravity, and capital G, the universal gravitational constant, we saw that mass m will be equals to acceleration due to gravity times the distance of the mass, square of the distance of the mass divided by universal gravitational constant. So therefore, me, which is our mass of the Earth, will be equals to small g, which is acceleration due to gravity, times the square of the distance, which is small r. So we have small r squared all over capital G, and that gives us equation 10. Now, if we substitute equation 10 into equation 9, we will have V subscript E to be equals to square root of 2 times capital G over capital R times small g r squared all over capital G. So the capital R down will cancel one of the capital R squared at the top. I will now be left with V subscript E to be equals to square root of 2 small g times capital R, and that gives us equation 11. That gives us the escape velocity. That is the velocity that any object will need to have for it to leave this Earth when it is launched or projected, that it will leave this Earth and it will never return back to this Earth again. So to calculate and know the velocity which an object will be required not to return to this Earth again when it is projected, this is the formula to be used. The capital R is the radius of the Earth, small g our acceleration due to gravity. Now we look at weight of an object in space. When an object, for example, a satellite or a rocket, is on or near the Earth's surface, when it is on the Earth's surface or near the Earth's surface, it experiences the full extent of the Earth's gravitational pull. However, if the object is launched into outer space, the weight of the object reduces. Why? Because the Earth's gravitational pull or acceleration due to gravity diminishes. The farther away an object from the Earth's surface or from the center of the Earth, the lesser the gravitational pull or the acceleration due to gravity acting on that object. So, the farther away an object from the surface or center of the Earth, the smaller the weight of the object. At a distance where the acceleration due to gravity is negligible, the object experiences weightlessness. And that is why in the moon, that's another planet outside the Earth, in the moon, you see that object floats because the mass of the object in moon is negligible, is very small. Why? Because acceleration due to gravity, the Earth's gravitational pull on that object in moon is negligible, almost not there, and therefore the weight of the object will be insignificant and the object will just be floating in air, and we call it weightlessness. Now, let's look at an example. Calculate the velocity of a satellite from the Earth's gravitational field, given that small g, acceleration due to gravity, is equal to 9.8 meters per second squared. Then radius of the Earth is equal to 6.4 times 10 raised to power 6 meter. Now, solution. We have our formula for velocity of escape as VE is equal to square root of 2 small g times capital R, where that capital R is the radius of the Earth. Now, substituting in our values, we have V subscript E to be equals to square root of 2 times our small g, which is 9.8, times capital R, which is 6.4 times 10 raised to power 6. And if you simplify, we will arrive at our answer as VE to be equals to 11 times 10 raised to power 3 meters per second, or 11 kilometers per second, because 10 raised to power 3, which is 1000, means kilo. Now, with this, we have come to the end of gravitational field. When next we meet, probably we'll be talking about electric field. Before I go, I will call on my colleague, Mr. Napoleon Kure, to come and review what we have said so far and then give you assignment. Till we meet in our next lesson.
Understood. He just mentioned what we have there on escape velocity and weightlessness of the body by telling us that the escape velocity is the minimum or the least velocity an object needs or require to be able to escape the influence of gravitational force of the Earth. And the object is immaterial. It can be a satellite, it can be a rocket, or any other planetary object that it needed to escape the field of the Earth. And he went on to establish the relationship between escape velocity, acceleration constant, that is universal gravitational constant, capital G, the mass of the Earth, and the radius of the Earth. If you are asked to calculate escape velocity, that formula also can be applied, whichever case. Now, he went on the next step to also derive the formula, that is escape velocity formula, by simply telling you that if you have a body, for instance, a satellite, and it is at a given point from the surface of the Earth, we discover that the work required to carry that body from that point to a point where the field influence, gravitational field influence of that satellite no longer works. That work done is the same as the kinetic energy of that satellite at that point where it's been taken to a point further away, which could be infinity. And so, with that, equations were being quoted. By the time you equate them, you will arrive at the escape velocity being equal to square root of 2 small g and capital R. So, the equation VE equals to square root of 2 capital G ME over R, or 2G capital R whole square root is the same, whichever one you use. And so, with what we have treated so far, he also went on lastly to discuss about the weight of object in space. Gravitational field law established by Isaac Newton help us to know that force of gravity on an object increases when the distance reduces between the Earth and that object. But if the distance increases, the force which by implication, the weight of that object will reduce. They are inversely related. That's just what it implies. And with that, therefore, it means that if an object is taken away from the surface of the earth, the weight will start reducing because the distance increases. So at a point where the distance is so far, like an infinity position, we discover that the weight will no longer be. And that's a case known as weightlessness. Now, an assignment will be given after an example has been solved for you to calculate the escape velocity given acceleration due to gravity or our gravitational field intensity, which is the same as that, or gravitational field strength and gravitational constant. Now we have the assignment given here. The escape velocity of a rocket from the earth is 11 kilometers per second, which is a constant. You are to take in the acceleration due to gravity as 9.8 meters per second square and then calculate the radius of the earth. Don't forget, sort out data. Assignment again. I say the escape velocity of a rocket from the earth is 11 kilometers per second. Taking acceleration due to gravity or our gravitational field intensity or gravitational field strength as 9.8 meters per second square, you have to calculate the radius of the earth. That's the question. And then for our references, it still remained number 1, New School Physics by M.W. Anyakoha. 2, All-Inclusive Calculations in Physics by Solomon Dauda Yako. And 3, Senior Secondary School Physics by P.N. Okeke and M.W. Anyakoha. In case of any question, any further clarification to be sought for, you can contact us via our WhatsApp or text message. Through this contact, Hassan Buki 080 6550 4346. Hassan Buki 080 6550 4346. And Napoleon Kure 08036362105. Napoleon Kure 08036362105. I remain Napoleon Kure. And don't forget, coronavirus is real. And so you are advised to stay home while you keep safe and then keep on learning. Wish you the best in your forthcoming exam. Till we meet in our next lesson. Thank you.